Hello viewers, welcome to Chemphilic. The channel Chemphilic primarily aims to create interest in chemistry. There are plenty of chemistry teaching channels where teachers are teaching different topics in details, sometimes a particular branch of chemistry in one shot, sometimes they are offering tips to crack the exams, etc. And all are excellent. But Chemphilic is a deviation from conventional path. It is an unconventional way of teaching from where it is expected that it will make the students to feel the subject matter. That's why chemical phenomena, laws, different compounds and elements are addressed as Mr. X, sometimes I, etc. And their characteristics are presented in a unique manner as if they are very common to us. Nucleophilic reactions are initiated by nucleophile, electrophilic by electrophile, and Chemphilic initiate the students' arch towards chemistry. So, my request is do watch the video till the end and send your feedback in the comment box. Now, let's start 30th episode of Teaching Chemistry through Riddle. Here is riddle number 30. X is a compound consisting of only two same functional groups and an active site. The functional group is derived from a parent functional group. Hydrolysis of X leads to formation of a compound containing two of that parent functional group and the same active site. The other product of hydrolysis is ethanol. X can easily remove one functional group out of two by a couple of simple reactions along with the formation of the second member of an aliphatic homologous series. Except for the first member of that homologous series, all other members, even the branch chain compounds of that series can be directly synthesized from X. X can also produce higher homologues of its hydrolysis product. So this is riddle number 30. Now let's see. Identify compound X. We have to find out what is compound X. Now let's solve the riddle and find out X. See, the clues given in the riddle are, first one, compound X is consisting of only two same functional groups and an active site. Second clue, the functional group is derived from a parent functional group. Third clue, hydrolysis of X leads to formation of a compound containing two of that parent functional group and the same active site. And the fourth clue, the other product of hydrolysis is ethanol. From this clue, what conclusion can be drawn? Let's see. The conclusion, first one, the parent functional group may be carboxylic acid group because carboxylic acid has different derivatives like ester, like amide, like anhydride, like acid chlorides, etc. As the other product is ethanol, the compound may contain ethyl ester functional group. That means COOC2H5. Then, the active site may be active methylene group because the compound has two functional group which is a derivative of what we have concluded that it may be derivative of carboxylic acid. And the third part is active site. So it may be active methylene group. So the compound may be, this is diethyl malonate. Now, diethyl malonate is hydrolyzed to dicarboxylic acid, then that is malonic acid. So, this is diethyl malonate. When it is hydrolyzed in acidic or alkaline medium, you will get this malonic acid plus this alcohol, that is ethanol. We know that esters are formed by the reaction between acid and alcohol, and hydrolysis of ester results the acid and alcohol. Now the next clue is X can easily remove one functional group out of the two through a couple of simple reactions along with the formation of the second member of an aliphatic homologous series. So let's see. So this is diethyl malonate, and this on hydrolysis it gives, already you have seen, malonic acid. Esters are hydrolyzed to acid and alcohol. And when this malonic acid is heated, then carbon dioxide is removed and acetic acid is formed. Acetic acid is the second member of the aliphatic carboxylic acid homologous series. First member is formic acid. Now, alkylation of diethyl malonate, let's see. As this diethyl malonate has active methylene group, so it can easily form carbanion. Therefore, when it is treated with a strong base like sodium ethoxide, carbanion is generated, and when this carbanion is treated with alkyl halide, then alkyl derivative or monoalkyl derivative of this diethyl malonate is formed. Now still one more hydrogen is there, so that can also be abstracted by base, and once again carbanion is formed, and when this carbanion once again reacts with alkyl halide, then we will get the dialkyl malonic ester. Now the next clue is, except for the first member of that homologous series, all other members, even the branch chain compounds of that series, can be directly synthesized from X. First member is formic acid, that cannot be synthesized directly. Acetic acid can be synthesized, already we have seen, and all other members as well as the branch chain compound also can be synthesized. Let's see. See, just now we have seen that this diethyl malonate can be alkylated because of the presence of this active methylene group which can form the carbanion. Now, this alkylated diethyl malonate, when hydrolyzed and then followed by heating, it will form this monoalkyl acetic acid. R is the another alkyl group. It can be prepared. So, when this dialkyl derivative of diethyl malonate is hydrolyzed, followed by heating, then carbon dioxide is removed and we will get the dialkyl acetic acid. Okay. Now, from this monoalkyl acetic acid, say this R group, if the R group is methyl group, then the compound form or the carboxylic acid form will be propionic acid. If the R group is ethyl group, we will get the butanoic acid, and so on. Similarly, from this dialkyl derivative of acetic acid, if this R is equal to ethyl, R dash is equal to methyl group, then the compound will be 2-methyl butanoic acid. Similarly, if R is methyl, R dash also methyl, we will get a 2-methyl propionic acid. Like that, the branch chain carboxylic acid also can be prepared. Now, next clue. X can also produce higher homologues of its hydrolysis product. Let's see. So, this is malonic acid. Dicarboxylic acid, first member is oxalic acid, second member is malonic acid. Other higher members are, say, this is succinic acid. Malonic acid contains 3 carbon atoms, 1 for CH2 group and 2 for the carboxylic acid group. Succinic acid contains 4 carbon atoms. Then glutaric acid. Glutaric acid contains 5 carbon atoms. And then adipic acid. Adipic acid contains 6 carbon atoms and so on. Now, we can prepare succinic acid, that is next higher homologue of malonic acid, from this diethyl malonate. What you have to do? You have to take 2 molecules of diethyl malonate and treat it with base sodium ethoxide. Carbon ion will be generated from these both the molecules and then treat it with iodine, whereby 2 molecules of sodium iodide will be removed and these 2 carbon atoms will be joined. Then hydrolysis, if you hydrolyze, esters will be hydrolyzed to acid group, followed by heating, carbon dioxide will be evolved and then this part will become ethanol, and from this part you are getting this succinic acid, 4 carbon atoms, 1, 2, 3, 4. So succinic acid. Next, glutaric acid. Same thing, you take 2 molecules of diethyl malonate and with the help of base prepare the carbon ion from both the molecules. Now treat it with diiodomethane, whereby also 2 molecules of sodium iodide will be removed and the CH2 group will be joined with both these carbon atoms, that means carbon atoms of both this molecule. Now again same, hydrolyze. Then acid group will be ester group will be hydrolyzed to acid and then heated, carbon dioxide will be removed and then ethanol will be produced and you will get from this part you will get the glutaric acid. 1, 2, 3, 4, 5 carbon atoms, glutaric acid. Now adipic acid. Here adipic acid means altogether 6 carbon atoms. Out of 6 carbon atoms, 2 carbon atoms for these 2 carboxylic acid groups and 4 carbon atoms for this CH2 group. Now take 2 molecules of diethyl malonate. Once again prepare carbon ion from both the molecules. Now treat it with 1,2-dibromoethane. Same, 2 molecules of sodium iodide will be removed and this CH2 to this group will be attached with both the carbon atoms. Then again same, hydrolysis, it will become esters will become acid and then heating, carbon dioxide will be removed and from here ethanol will produce and this part will become adipic acid. See, 1, 2, 3, 4, 5, 6 carbon atoms, so adipic acid. Now, about diethyl malonate from the Riddle, what we have observed. Diethyl malonate is consisting of 2 esters group, that is CH2CO, C2H5 and an active methylene group. Hydrolysis product of diethyl malonate are malonic acid and ethanol. Diethyl malonate on hydrolysis followed by heating results the formation of acetic acid, carbon dioxide and ethanol, we have already seen. Except formic acid, which is the first member of homologous series of carboxylic acid, aliphatic carboxylic acid. All other members of the carboxylic acid homologous series as well as branch chain carboxylic acid can be directly prepared from diethyl malonate. Next, from diethyl malonate, higher members of the aliphatic dicarboxylic acid can be synthesized. Just now we have observed. And last one, diethyl malonate can generate carbon ion due to the presence of active methylene group and form mono and dialkylated malonic ester. So this is the end of the Riddle. Thank you.